12.3, using proportional relationships, geometry. Essential question, how can you use similar triangles to solve problems? The answer, you can use similar triangles to measure things indirectly, using the fact that similar triangles have side lengths that are proportional. So here we are with proportionality again. Definitions. Indirect measurement involves using the properties of similar triangles to measure such heights or distances. So, in real life, you can do magic with math, okay? Let me explain. You already know that your height, okay, is 6 feet. Okay, that's you. Your height's 6 feet. Your shadow is 4 feet, and you're like, okay, my shadow is 4 feet, that's awesome. And then your other friends are like, you know, just hanging out, and they're like, hey man, do another magic trick, and you're just like, oh geez, okay, well, I'll use indirect measurement. And you're like, I know the height of that, I can calculate the height of that flag for you. And they're like, really? The height of the flag? Okay, well, go ahead, prove it to us. And then you're like, okay, in your head, you're like, okay, I'm definitely 6 feet. And then you take, you know, 4 steps to the edge of where your shadow was, and you measure 4 feet. And then all of a sudden you walk to the base of the flag, and you measure out its shadow to 10 feet. And the shadows, both of these shadows are created by the sun. Okay? I see the sun sees me. So the sun's just shining. And what's kind of cool about this is, do you guys remember angle similarity? Both these angles of the shadows by both humans will be congruent because they're sharing the same light source, the sun. Okay, don't get me wrong, it's off by like 0.000001 something because the sun's like really, really far away. Okay, but again, for most mathematicians in history, it's been quite useful. So, both of these triangles should be similar by the AA. And then you're like, okay, let's see. H divided by 10, 6 divided by 4. And when you're comparing two different objects, set them equal to each other, right? So just remember, your proportionality statement should be something like, okay, this guy is proportional to this guy. And then this guy, the shadows, should be proportional to the shadows. You do some quick math. Okay, I have the height, okay, over 10, equaling my height over my shadow's height, which is just 4, compared to the flag's 10. Okay, cross multiply. You're going to get 4h equals 60. You're going to just divide by the 4, division property. And then you're going to just go, okay, the answer is definitely 15. Alright guys, the flagpole is 15 feet. And they're just like, what? How did you do that? And it's because, you know, you didn't climb up with like a ruler or something sad to the top of the flag. You just use indirect measurement. You never climbed up the flag to measure it. You just kind of used proportionality of two triangles to use indirect measurement. So that's a nice little magic trick. All right, example 1. It's exactly like the flag. Basically, you're going to find the height of this palm tree. So you already know, or should know, that the palm tree is going to be proportional to this wall or fence, and that the shadow should be proportional to the other object's shadow. Therefore, you're going to set up your proportionality statements. So the palm tree is proportional to the wall, and the palm tree's shadow is proportional to the wall's shadow. So we substitute for our known measurements, cross multiply, and AB is 4.5. In context, this palm tree is 4.5 meters in height. And notice, you know, nobody had to climb up a palm tree, and let's admit, palm trees can get pretty up there, and they look all bendy and scary, so that's also kind of nerve-wracking. All right, example 2. So we already have our answer at the bottom because, you know, somebody was tired, okay? But basically, let's say this. Let's say you have a friend, all right? And how about this? Pretend this doesn't exist right now, okay? You have this friend, and they are like a perfect 10, all right? They're just like the best. And you're like, okay, I want to make sure this person, like, stays around, so, I can definitely, like, ask them out or something. And this person happens to be a daredevil, all right? They love jumping canyons with their car, all right, or their motorcycle. And you're just like, oh, that's so cool. She's like, this person is awesome, okay? And all of a sudden they're like, yeah, I'm going to jump this canyon with my bike. My bike can clear like 200 feet. And you're just like, oh, okay. And you're looking at the canyon and you're like, is that 200 feet? Like, oh, God, like if this person doesn't make that jump, if this person doesn't make this jump, I'm going to be very sad. Okay, I'm going to be like epic sad. And I don't want that. So you start walking and counting your steps, and you have perfect 12, inch shoes. So you're walking across this canyon, and you're looking for the distance, and you can't climb across, you can't float across the canyon. Okay, so you can't really like measure out that way directly. You have to go indirectly. So you walk, and you create two triangles. Okay, you start thinking, okay, this guy's got to be proportional to that guy. This guy's got to be proportional to this guy, and both are right triangles. So all you had to do in real life is you walked out this way. You were like, okay, that's 400 feet. I'll start my new triangle. 600 feet. Then you walk a perfect 90 degree, 327 degrees. And then now you can use your indirect measurements. Set up your proportionality statements. And just imagine, like, that person's in the back, like, warming up their engine, and you're just like, okay, I gotta check. And you're doing your proportionalities. You substitute in your variables, all right, your numbers. Cross multiply, and the book also notices that 400, it also notices that 400 divided by 600 is the same as 2 over 3. Okay, so just note that. And then ultimately what happens is you get, for XY, 218. Now remember the context, okay? You don't want this person to not make the jump, okay? So you're like, oh, that's 218 feet. Oh, God, and she's going to, like, this person's going to, like, fly over this canyon and just, like, so you run up there and you're like, hey, I measured 218 feet using indirect measurement. You can't make the jump. Please don't do it. And then that person's like, hey, thanks. You saved my life. You want to, like, go out for, like, a coffee or something? And you're like, yes, please. All right. So, epic win for the win. And you just saved some perfect 10's life because you knew indirect measurement and proportionality. All right, so example 3, there's this river, okay, and you don't want to get your feet wet because maybe it's a radioactive river or there's crocodiles. Who knows what's in this river, okay? So you go ahead and use indirect measurement because you don't want to swim through the river to measure the total distance across the river. So we use indirect measurement again. Also, fun fact, again, vertical angles, all right? And these guys are right angles. So when you see these kind of triangles, you already have the AA similarity going on, all right? So remember your proportionality. This guy's got to be proportional to this guy. This guy's got to be proportional to this guy. So we go ahead and set it up. And then green guys with green guys. Go ahead and substitute. And then cross multiply. 12 times 12, 144. 144 divided by 6 is 24. So in context, the distance across this stream is 24 meters. And you didn't have to get wet. All right? There are humans out there, and I've met them. They will go across the stream and get wet. Okay? And, man, who knows? Who knows? It could go wrong in all kinds of ways. So if you really want to just do indirect measurement, it's easier that way. Okay, so those were enough examples for you. Just remember your proportionality statements and how to write them. And there it is, page 657 through 658, numbers 1 through 13. Number 1, well, look at your notes for the definition. Okay, good luck.